So today I'd like to briefly look at some pre-calculus questions where we're told to use the information below to find the cosine of alpha minus beta. Now we don't want to complicate too many things here or think too much into it. Let's go for a brute force method where we can just apply most of these formulas and with some mathematical reasoning get to an answer. First and foremost, what you want to remember is that you're working with sum and difference identities for such questions. So if it says the cosine of a minus b, refer back to the sum and difference identities and just look at what they are. So here it says that the cosine of a minus b is equal to the cosine of a times the cosine of b plus the sine of a times the sine of b. Now this is just alpha and beta. These are just arbitrary angles, right? Just as we would call theta an angle, alpha and beta are just different angles as well. So you really want to follow this step-by-step process in order to answer the question accurately. So first and foremost, we're going to deal with this formula here. So let me go ahead and grab that formula. Okay. Now, in doing so, we would need the cosine of A and the cosine of B and the sine of A and sine of B. So let's work first with the cosine of A and the cosine of B. So the cosine of alpha, right, which I'm calling A, they're saying is equal to 4 over 5. And it is essentially, and let me actually move this down a little bit. It is 4 over 5, and it's in the fourth quadrant. So we're looking at a unit circle here, and we're really looking for a cosine of some angle which is equal to 4 over 5 in the fourth quadrant. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and then this is quadrant 4. So we're looking at the fourth quadrant, right? Because that's where the angle is, which is cosine. And if we are looking at a terminal angle or a terminal side in quadrant 4, we'd be looking at something that looks like this, right? So if we were to drop a perpendicular, we're really looking at a triangle that looks something like what I've drawn here. Now, one thing to sort of remember is that the y value, which is of course, which is this here, reflected on the y-axis is negative because we have a negative y-axis here. So this quantity is negative, okay? And since we're in the fourth quadrant, the x value here is positive. So let's just take this triangle with us here and essentially sort of redraw it to see what we're working with. So if we have our angle here, our adjacent side would be here, our opposite side would be here, and our hypotenuse would essentially be here. So we're told that the cosine of some angle is 4 over 5. And the triangle for that angle would look something like what I have here. So the cosine of some angle is equal to 4 over 5, right? Now, the thing that I want to draw your attention to is SOHCAHTOA, right? So SOHCAHTOA essentially tells us that the cosine is equal to the adjacent side over the hypotenuse side. So the cosine is equal to the adjacent over the hypotenuse of any particular angle. Now, for this angle, which we're calling a triangle, which we can think of as a triangle, is the adjacent over the hypotenuse if we're referring to the cosine. So really, I can say that since the cosine of some angle in quadrant 4 is 4 over 5, then the adjacent over the hypotenuse for that triangle, which is a over h, is in fact identical to this. So we can say that our a is equal to 4, and our h is equal to 5. So that's essentially how we've deduced what the adjacent and the hypotenuse is. However, we still don't know the opposite side, right? In order to find the cosine of alpha, um, we would actually have to do, according to SOHCAHTOA, we would have to do the adjacent over the hypotenuse. That's not going to pose any problems for us, but as we move forward, we'll have to use the opposite side as well, and we would need to know what that value is. So what we're going to do, given that this is a right angle triangle, is we're going to use the Pythagorean identity or the theorem to solve for the last side here. Um, so we have the Pythagorean theorem, which states that h squared equals a squared plus o squared, which is really just h squared equals x squared plus y squared. We're just talking about x and y coordinates here. So you can think of a as being your x coordinate, remember, and your o as being your y coordinate. So we know what h is, right? That's 5. So 5 squared is equal to a squared. We know what a squared is, right? That's just 4 squared plus o squared. So we have 25 equals to 16 plus o squared, and then o squared will essentially equal 25 minus 16. So o squared equals to 9. O equals to 3. So this is how we've used the Pythagorean theorem for the O part of our triangle. And now we can very easily find out what the cosine of A is, right? Because this is for our alpha angle. So it correlates with the cosine of A. So the cosine of A, remember, it's just A over H. Well, that's just going to be A over H in this case is just 4 over 5. So the cosine of A, alpha, is equal to 4 over 5. Now, one particular thing to remember in this case is as we move forward, we want to keep track of the sign attached essentially to the numbers. So now that we've found the cosine of A, we also have to have sine of A as well. So let's go ahead and find sine of A. Remember, this is for the A angle, right? Alpha angle. So everything that has alpha in it applies to this triangle. So the sine of alpha in this case, we know that SOHCAHTOA tells us that the sine is O over H. And O over H in this case is O over H, which is 3 over 5. So the sine of alpha is equal to O over H, right? SOHCAHTOA, which is just 3 over 5. Now, one thing to remember here, and I really want to stress this out, is the triangle. We got this triangle from the fourth quadrant. And I told you when we started out that this side here was negative, right? It's the y value. The y value in the fourth quadrant is negative, which means that since this triangle is essentially the same thing as this triangle, this value here, which is just O, is actually negative. Okay, so that's negative 3 over 5. That's, I think, pretty important to remember. So our cosine of alpha is 4 over 5, and our sine of alpha is negative 3 over 5. Now, we want to move on to finding the cosine of B and the sine of B. So we're now not dealing with the alpha part of things. Now we're dealing with the beta side of things. Now we're told that this angle, this beta, the tangent of that angle is 3 over 4 in quadrant 1. That's just a clue. It's just a clue. So we have what the cosine of A is. We have what the sine of A is. We're looking for those other two parts, the sine of A, or rather the cosine of B and the sine of B. So we just essentially repeat this whole process, right? So we just do this again. So we're told that the tangent of beta is equal to 3 over 4. But due to the SOHCAHTOA here, we know that the tangent of theta is O over A, right? So O over A. And we know that since this is a parallel, our opposite side of of our triangle, which is clearly in the first quadrant, is 3, and our adjacent side is 4. So let's get a good idea for how this triangle looks like. So these are our quadrants here, and we have our quadrant 1, and then we have quadrant 2, and then we have quadrant 3, and then quadrant 4. So the tangent of beta is this angle whose tangent is 3/4 is in quadrant 1. So that means we're looking at a triangle, any arbitrary angle that looks something like this. So just extrapolating this here, and this is our next question. Let me move that a little bit down. So in this case, our triangle, really, if we were to bring this out here, looks like our average right triangle, right-sided triangle. And our angle in this case would be here. That's where our angle subtends. So in this case here, we want to recognize that we have our opposite side, our adjacent side, and our hypotenuse. And we know that O in this case. Let me change the color actually. We know that O is actually, let's just keep it the same. We know that O is equal to 3, right? Because of what I explained here. And our adjacent side is equal to 4. We want to essentially find the hypotenuse, which is actually what we don't know. So we want to again leverage the Pythagorean theorem to actually be able to solve for the hypotenuse. So I think maybe this may be a little wrong here. If we're in the first quadrant, then if we're in the first quadrant and our tangent of theta is 3/4, we have O over A, and our O is here, our A is here. So let's see. Right, so essentially our H in this case is our unknown, and we're using the Pythagorean theorem, which says H squared equals O squared plus A squared. And that's just both sides of the triangle squared. So H squared is equal to O squared, which is 9, plus A squared, which is 16. H squared equals to 25, therefore H equals to 5. So our H is equal to 5, which means that the sine of beta, in this case, we know that SOHCAHTOA tells us that SOHCAHTOA, or the sine, is O over H. So O over H in this case would be O over H, which is 3/5. And the cosine of beta, which of course I'm finding because I have to plug it back into the formula. The cosine of beta is A over H, going off of the mnemonic here. So A over H in this case would be 4/5. So these are essentially our values, and we essentially plug these back into the formula. So it's asking for cosine of A. We found cosine of A, cosine of alpha, which is 4/5, right? So we have 4/5. And cosine of B, in this case, we would come here, is also 4/5. So we have 4/5 for this one as well. Plus the sine of A. Now the sine of A, in this case, is going to be a negative 3/5. So we have negative 3/5. And that's multiplied with sine of B. And sine of B in this case is 3/5. And if we essentially plug this into a calculator, we should get 7/25, right? Because we'd have 16/25 here, and then minus 9/25 here. That just gives us 7/25, which is our answer. So that is for the first question. Now moving on to the second question. It is essentially the same exact steps. So we figure out which one we're going to use. We're using the tangent formula, a plus b, or alpha plus beta. And the tangent alpha plus beta formula is right here. So in this case, we're told that the cosine of this particular angle is 12 over 3 in the first quadrant. So again, it's just a clue. So the cosine, we're in the first quadrant, right? We have an angle, and the cosine of that angle, if you were to think about this as a triangle, is 12 over 3. So we're looking at a triangle that looks like this. And of course, the angle is here, and we have an opposite side, an adjacent side, hypotenuse as well. So we have O, we have H, and we have A. Or actually, we have O, we have H, and we have A. And let's see here. So the cosine of this angle is 12 over 13. Um, so the cosine, right? So we know that the cosine of this angle of alpha in this case is equal to 12 over 13. And we also know that the cosine of anything, of any angle, is a over h. So a over h, so SOHCAHTOA, which means that 12 is our adjacent, 13 is our hypotenuse. So our hypotenuse is equal to 13, and our opposite side, or our adjacent side rather, is equal to 12. Therefore, we're solving for our opposite side. So with the Pythagorean theorem, 13 squared equals a squared, or 12 squared in this case, plus o squared. That should be 169 equals 144 plus o squared. And then 169 minus 144 equals, let's see here. So we have 169 minus 144. If we subtract that, we'll essentially get 25. And O equals 25 in this case. So O for this triangle is 25. Now, it is in the first quadrant. So the cosine of A is, so actually we're looking for, what are we looking for first and foremost? We're looking for the tangent of A. So the tangent of A is O over A, given SOHCAHTOA. So O over A in this case is 25 over 12. Let's double check that. So we're looking for the cosine in the first quadrant. Cosine is equal to 12 over 13 in quadrant 1. And let's see here. The tangent of theta is O over A. Right, so it's actually not 25. It can't be 25. It's actually 5, right? Because we had to solve this bottom portion here, and we would get 5 in that case. So if we had O squared equals 25, O equals 5 in that case, right? So the tangent is the sine over the cosine, and the sine in this case is, so the tangent is sine over cosine, and we know that, well, we can think about it as a sine over the cosine, or we can think about it as O over A. The tangent of A is O over A, right? So tangent for A would be O over A, which is 5 over 12, right? And that is the tangent of A, okay? And the tangent of, and now we're looking for the tangent of B. So same process. The B is equal to, it's in quadrant 2, so we're looking at this triangle here, and it looks something like this, and we're going to draw an angle. We have an opposite side, an adjacent side, and a hypotenuse. So we have O, we have H, and we have A. Now, in this case, our X value will be negative. We want to keep that in mind. And our Y value will be positive because we're in the second quadrant. And we're told that the cosine of beta is negative 12 over 13. So the cosine of beta is negative 12 over 13. And we also know that the cosine is A over H, which means that A is equal to negative 12 and H is equal to 13. Now, A is negative 12, so we're just going to have that there. And H is equal to 13. And we're looking for O. So H, so if we do H squared equals A squared plus O squared, then H squared in this case would be 13 squared equals negative 12 squared plus O squared. And that's 169 equals 144 plus O squared. Same assessment, where O squared equals 169 minus 144. So O squared equals 25, O equals 5. And then, of course, since our X value is negative here, we're going to have to put a negative for our opposite side. Or actually, since it's O is opposite, that's our Y value, so that's going to be positive. Okay, so we know that O is positive now, or O is positive 5. Okay, which means well, it means that our tangent of B, right? So this is essentially what we want to pay attention to. Our tangent of B is essentially going to be equal to O over A, and O over A in this case is 5 over negative 12. And yeah, so that's our tangent of B. So we have our tangent of B and we have our tangent of A. So let me just rewrite this. So our tangent of B, let's see here. Our tangent of B is going to be 5 over negative 12. Tangent of alpha is going to be 5 over 12. And we're plugging into this formula, which says take the tangent of A, which is 5 over 12, and add it to the tangent of B, which would just be negative 5 over 12, over 1 minus the tangent of A times the tangent of B. So that's just 1 minus the tangent of 5 over 12 minus, or multiplied to the tangent of B, which is negative 5 over 12. Now, if we have a fraction, of course, which goes to 0 in the denominator, then the entire answer is 0. And that's actually what you'd expect for this answer. So for this answer, the answer is in fact 0.